Hey, sixth grade, and welcome to section 4 of chapter 4. This is the last lesson in chapter 4. Today we're going to be discussing polygons in the coordinate plane. So many-sided shapes in the coordinate plane. Remember, a coordinate plane is kind of like a graph, is another way to kind of say that. All right, today for our learning target, we have I can draw polygons in the coordinate plane. I'm just going to abbreviate. Okay, and then find distances and find their distances. Okay. The first piece of information we get here, maybe just star this. This is a good reminder, but it says you can use ordered pairs to represent vertices of polygons. Okay. Vertices are like the corners of shapes. And remember, an ordered pair is always listed as x, comma, y. So first is your x, which is your right or left, and then is your y, which is your up or down. Okay, for now we're just going to be working with right and up positive numbers, but eventually you'll be working with negative numbers, so you can go left and also down. Okay, it says to draw a polygon in a coordinate plane, plot and connect the ordered pairs. All right, let's see what that looks like in the first example here. The vertices of quadrilateral A, B, C, and D are these ordered pairs. So 2, 4, 3, 9, 7, 8, and 8, 1. Okay. Draw the quadrilateral in the coordinate plane. All right, here's our coordinate plane. Our x is always going to be our horizontal. You'll see it's labeled here for you. And our y is always going to be our vertical. One way you can remember that, and what I've had students do in the past, is when you make a capital Y, the stem here is going up and down. So that's how they remember that Y is the vertical axis there. Okay? And remember, first is your X. I'm going to just draw parentheses there. And then is your Y. Okay? So we always go over left or right first with our first number, and then we go up or down with our second number. So for A, we have 2, 4. So over 2 on the X and up 4. 1, 2, 3, 4. That's our first point, and I'm going to label that. Oh, why does it keep erasing like that? Letter A. Okay. And B, next is 3, 9. So right 3, up 9 would be right here. So that's letter B. Letter C is 7, 8, over 7, up 8. Okay. So that's letter C. And then lastly, I have D is 8, 1. So over 8, up 1, and that's letter D. Okay. And then all you need to do for your last step is just connect all of those points, or all of those. The fancy word is vertices. It's just pretty much like saying corners. Okay. On your piece of paper, if you have just like a ruler handy or a straight edge of a book, maybe use that. With my computer pad here, it's a little bit tricky, so please forgive me if my lines aren't exactly too straight. But there you have it. And that's all you need to do is just be able to draw it. Okay. For the on your owns here, I have 2 graphs that I've set aside for you. So put like 1 and 2 on one graph and 3 and 4 on the next. Why don't you go ahead and pause the video and see if you can do this. Okay, it's kind of handy for me because I can use different colors here. Maybe you want to think about doing that when it comes to your homework. So for number 1, I've got 0, 0. I've got 5, 7. And I've got 7, 4. Okay, so it's going to be this triangle shape for number 1. Okay, I'm going to use a different color here for number 2, and it's 4, 4. So over 4, up 4. Oh, don't do that to me. 7, 4. So over 7 up 4, same as that other point. 7, 1. And then 4, 1. So I'm going to have a square here. So that's number 2. Notice how they overlap. If you have problems like that on your homework, I would say please try to do different graphs. I just put 2 graphs on here just to save some space on our note sheets. But if you have that in your homework, please make separate graphs. Number 3, I have 1, so over 1 up 3 for letter F. I have 3, 6, which would be letter G. I have 5, 6, which is letter H, and I've got 3, 3 for letter J. Okay, and here, this shape, I have a parallelogram. And lastly, we've got number 4. I'll try to pick a new color here. And I've got 1, 4 for P, over 1 up 4 for P. I've got 3, 5 over 3 up 5. It's a little bit close, as you can see here, so it gets tricky. I've got 7, 3 over 7 up 3 for letter R. For S, I have 6 and a half, so I've got over 6 up a half. So I'm not going to go up 1. I'm just going to go up half the way to 1. That's going to be letter S. And lastly, I've got 2 over 2 up a half for letter T. Okay. Notice here I've got 5 points, so I'll have a 5-sided shape, which is a pentagon, and it should look something similar to that. Okay. Well, let's move on to our key idea next, where it says you can also find distances in the coordinate plane. You can find the length of a horizontal or a vertical line segment by using the coordinates of the endpoints. When the x-coordinates are the same, the vertical distance between the points is the difference of the y-coordinates. When the y-coordinates are the same, the horizontal distance between the points is the difference of the x-coordinates. Okay, so in other words, you're just subtracting to find the distances, okay? It says be sure to subtract the lesser coordinate from the greater coordinate. All right, in example 2, it asks us to first draw the rectangle and then find its perimeter. Okay. Excuse me. Oof, hopefully that didn't startle you. If you say, bless you, Mr. Gillis, I'll know what you're talking about. The vertices are 1, 6, over 1 up 6, that's letter F. 7, 6 over 7 up 6, that's letter G. H is 7, 2 over 7 up 2. And J is 1, 2 over 1 up 2. That's J. Okay, here we have our rectangle. And then it wants us to find the perimeter. Remember, perimeter is the distance around the outside of something. Okay, so here I've got 1, 2, 3, 4, 5, 6 for my length. And notice from F to G, my y-coordinates are the same. They're both 6. If I just took 7 and subtracted 1, I would come up with that length of 6. Okay, so this would have to be 6 on the bottom as well. And then I could do G to H. I'd have 1, 2, 3, 4 units. And again, if I went from G to H, my x's are the same, but if I took 6 minus 2, I'd come up with that 4. So this side would have to be 4 as well. I add those up. 6 and 4 is 10. 6 and 4 is 10. 10 and 10 would give me 20. And my label will be units for my perimeter. See, I'm running out on time. We'll be back with example 3 in just a second. Okay, picking up with the real life application. It says in a grid of the exhibits at a zoo, the vertices of the giraffe exhibit are 0, 90, 60, 90, 130, and 0, 30. The coordinates are measured in feet. What is the area of the giraffe exhibit? Okay. So for the first part of information, what I think is important to understand is that our grid here, look at how big our numbers are. We've got 90s, hundreds, and for us to make each one of these squares one, that would stink. We'd have to tape pieces of graph paper together, and that would just be no fun at all. So the trick that I'm going to tell you is that you can make these increments here, each one of these blue lines, worth more than one as long as you're consistent. So if you look at these numbers, you'll see that all of these are divisible by 10. So if I am going to choose a different scale here, I'm not going to go by ones. Rather, I'm going to go by tens. Whoops, not sure what happened there. Let me get my eraser. Okay. Notice on this one too how you have to make your own X and Y axis here. It's not for you. That's how it'll be with your homework too. You won't always have those, so you'll have to make them. Okay. Continue on with the lines. Label this one Y, this one X. And our first point here is going to be 0. And then, like I said, let's go up by tens. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, so on and so forth. And let's do the same here. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay? Just making sure I'm going by the same increments there. Okay. Now I don't have to go by ones, and it'll make this a lot easier. So my first point is 0, 90. So that means over 0, okay, that'd be on this line, and up 90. Here's my first point. F is 60, 90, over 60, up 90. G is over 100, up 30, over 100, up 30, 10, 20, 30. And lastly, 0, 30, so over 0, up 30. Oops, this one disappeared. This one was 100, 30. So then I can draw my shape. Looks like I have a trapezoid here. Looks like these two sides are parallel. All right. And then it wants us to find the area. Okay, well, remember the area formula for a trapezoid is area equals a half times the height times the bases added together. So B1 plus B2. Let's count and see how big our bases are. And remember, we're going by tens. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. All right? And let's count for our top as well for our other base. 10, 20, 30, 40, 50, 60. So this would be 100 plus 60. Times our height, how tall is it? Well, from one base to the other is 1, 2, 3, 4, 5, 6. So we're going by 10, so that would be 60 times a half. Okay, well, half times 60 would give us 30. Okay, and then we have to take 30 times 160, because 100 plus 60 would be 160. Okay, well, I know 16 times 3 will give me 48, and then I have 2 zeros that I need to add to that. So I come up with 4,800, and my label, it says it's measured in feet, so that would be feet squared, since I'm talking about area. All right, so that would be how you'd go about solving for the area for that giraffe exhibit. Okay, that does it for lesson number 4 and polygons in the coordinate plane. Please let me know if you have more questions, and I will see you next time.